All right, so if I can get most people's attention at least, welcome to the Python workshop. It is being hosted by the Undergraduate Artificial Intelligence Society and ADAS team. My name is Giancarlo. You can just call me Gino. I am part of the UAIS, the Undergraduate AI Society. I'm the General Secretary, and the reason that we are teaching Python now is because it's the second most popular language in the world, and it is used for a lot of data science and machine learning. And as a AI focused group, we like machine learning, so a lot of the projects we use or we work on are made in Python. So if you ever want to join us later, that'd be great. Yeah, we'll be doing pretty much everything on Python. But you can use Python for pretty much anything else. There's libraries for pretty much anything. You can do web development. You can do pretty much anything in Python. It's a very nice language. So this workshop will... also big shout out to ADAS team again for helping us out with this. Python is an interpreted language, which means you just don't have to compile the code before running it. The code you type is the code you can run directly. And this is the only precursor we have. So we're going to be talking about what makes the Python language unique. So to start off with, we'll be touching on variables and how they work. So if you've ever worked on another language, such as C, for example, you'll know that any variable that you define has a specific type when you define it. So if you want to define an integer, you have to, when you go and define it, you'd have to say this is going to be an integer. So in this case, I'd have to say the integer a is going to equal to 1. In Python, we don't do that. In Python, we just call a variable and then we give it a value. There's more than that. The value is implied. So here we say a is equal to 1. We automatically know that, well, we know, and then the Python interpreter is going to know that a is now a integer. And then later on, when we do a times 1.0, we convert it to a float, which is basically a decimal. So if I run this program here, so I call Python, and then I run the file vars.py. There we go. So you can see the first time, so in line 3, I print its type as an integer. Same variable, I change the type. It's now a different type of variable. So on the fly, you can change what type the variable is, unlike some other languages, which would throw you an error immediately. Another thing is that, again, if you come from from C or any C-inspired language, such as Java or C++, you're used to, I'll open my Python interpreter for this, you're used to, if I say a equals 1, if I want to increment it by 1, you're used to doing a++. In Python, that doesn't work. Why? Not my problem. But that means you just can't do it. But you can still do the use another operand, which is the plus equals, which is pretty much in every other language that at least I know of. So if you a is plus plus, that will not work. But you can still use a plus equals 1. That also goes for the decrement operand. So minus minus, just do minus equals 1. And that's pretty much everything in terms of the variables. The next thing would be logic. So logic operators are simple but different in Python. You can also use bitwise operations if you need it. That's more so if you're coming from C, but in my experience, I've never really used them. So I wouldn't really worry too much about it, but they still work the same way. But if you are coming from another language, again, it's a C-inspired language such as Java, C++, or C itself, you're used to having, when you're making Boolean statements, so true and false statements, you may be used to typing, for example, the double pipe signs for or, the double ampersands for the and, right? When you say something is true and false or true and true. Or if you want to say that it's the opposite, so a negation, a not, you would be using an exclamation mark. In Python, depending on what you think, it's easier or I guess a bit more confusing, but you just type the word in English. So if you want to use and, you just type and. If you want to use or, you just type or. If you want to do not, you just type not. So again, I'm just going to open my Python interpreter, but you can have a file like this. And if I type true or false, like in some other languages, it'll throw me an error. But if I type the word or, now it actually gives me back a statement. True or false being true. If I actually run the file that I have here, which is all just these statements, you'll see that pretty much for all your cases, you'll be able to do this in Python. So Python logic.py, false, true, false. I'm not getting any errors because I'm using the way Python does it. So again, that's also fairly simple, but it's a fundamental part of Python. So if you don't know this and you're getting to a lot of errors, it might be hard to find out why, but this is why. So the next thing will be for loops. We won't really talk about while loops and while do loops. While do loops don't, to my knowledge, don't quite work in Python, but there's easy ways you can implement that. While loops work pretty much like in any other language, so there's no real difference there. But the difference does come when you are using for loops. So if you use a language such as C#, for example, you have for loops and you have for each loops, which kind of do the same thing but do something different. Where a for loop will loop from basically an integer or a float at some starting value to up to but not including another value, and increment or decrementing by a certain value, such as I have the examples right here. And then you have something like a for each loop, which is looping for elements of an array or a list or some other iterable object. In Python, you essentially only have a for each loop, but they're just called for loops. So here, we have a for loop that would be implemented in, let's say, C. So now if you want to implement this actually in Python, you'll be doing something slightly different. So you'll be going for the element in, and then you actually give it the list, array, whatever it is that you want to iterate through. In this case, I can give it 1, 2, 3. I can do print the element. I save that. Now I run this. It'll give me 1, 2, 3. Now, this is more useful when you actually have something that's already defined on the spot. Let's say you just want to loop through a bunch of numbers, but obviously you don't want to type this all out. There is a handy included function in Python, which is called range, which works kind of the default in this example. So if you just give it 5, and you don't give it any of the other optional arguments, it'll print 0, 1, 2, 3, 4. So it goes up to 5, but not including 5. But it starts at 0 by default. So now in this other example, we don't want to start at 0. We want to start at -3 or -3. So we, again, still give it the range. But now the first argument we'll give is -3. And the second argument we'll give it is 4, +4. Forgot to actually print something. So now we run this. Now make my thing full screen. You'll see that I'm still running this from the previous loop, but now when I'm running this, it's actually running from -3 up to, but not including 4. Now I guess for the last one, I comment these ones out. For the last one, I want to go, again, just start at 0 because I don't really care, but now I want to increment it by 2. And this is where the third argument in the range function works. So again, for the element, I'm just going to go in range. I'll start at 0. I'll go up to, but not including 10. And now I'll increment it by 2 every time. I've run that. You can see here, I start at 0 and I increment it by 2 every time. 0, 2, 4, 6, 8. And then it doesn't print out 10 because it is excluding 10. So that is the basis of for loops. Now, if you had some other iterable object that we might be touching on later, if I remember correctly, you'll see you can pretty much use it for that as well. But again, it's just like a for each loop in other languages. So if you know those, That's how it works in Python. It's just if you're used to using the normal for loops where you iterate through certain numbers in a range, use the range function. Now moving to actual functions. So here's how Python functions are structured. So here I define a simple function right here. So when I'm gonna call a function, I define. So I just call the def token. I give a name to my function. And now in this case, I'm giving it an argument because I want to do something with this name, for example. So we've rerun this. Python functions.py. Get myself an interpreter. So now if I call hello1 and I give it a name, or technically doesn't have to be a name, but it's just something as an argument that I can pass it through. So I give it John. It's going to print out hello John. That's what this print statement is doing. What exactly the print statement is doing, we'll be touching on later when we move on to strings, which will be next. But for now, here's how we can do something very similar, which does almost the same thing, but slightly different. So in the first one, when we used hello1, we have to give it a name. If we give this empty, it throws an error. It says that we are missing an argument. But let's say I don't necessarily want to give it a name. Let's say the user, if we're making an application, the user give me a name, well, let's just give it a default name. So this is what we're doing now here in hello2, where we're still calling this variable name, but if they don't define it, it's going to be defaulted to some variable that we define. In this case, I use Gertrude. And again, same thing here, it just printed it out. So now if I run hello2, I don't give it anything, it says hello Gertrude. If I actually give it John again as an argument, it does hello John. So now you can use optional arguments where it defaults to a variable that you defined beforehand in case no argument is given. Now, how do you restrict variable types for inputs? So again, if you use another language, when you're passing in an argument, you already tell it that it's going to be a string, it's going to be an integer, it's going to be a float, for example. In Python, since you can give it any variable, any type of a variable. So for example, in this case, I didn't do it, but if I do hello1 and I give it a 2, for example, it's gonna accept it. It's gonna say hello2, even though that doesn't really make sense. Why would a name have just be a number? So what you can do here is you can assert them. So here we're using the assert statement in Python, which is essentially it goes for the type of the name has to be a string, and then here is just for debugging purposes, but it is optional. After the comma is we're gonna throw a little error statement. So if we actually run this, so hello3, and now I give it a name, I give John again, it works just fine. But now if I give it a number, for example, like 2.0, now I get an error. Now it's only going to be accepting strings. And of course, you can do a bit more complicated stuff. Now we've been using arguments in all of these. What if you just don't want it to do anything? Like no arguments, for example. Well, you just don't give it an argument. What if you're starting out your code and you still don't want to implement what that function does, but you still want to have that function written out? So in Python, we can just do pass in a certain line, which just does nothing. All that will do is it'll just say pass, don't do anything at this line. The reason you want to do that and you don't want to have it just empty is because Python is indented. So when you have this and you don't have anything afterwards, it's going to throw you in an error. So now I'm just going to save this to show you. With this. Actually, it doesn't even give you the, actually, yeah. It gives me the error here saying that this is not indented because it's assuming it would be part of this because there's nothing here. That's why if we give it now the pass, again, the function will do nothing, but if we give it the pass, I can run this function and I get no errors. I can go back to here. The last thing we want to do is, what if we want to do something like the print statement in many languages, where you can print out many different things and you give it many different arguments, but they're not always fixed. In Python, you can also do that. The way you would do this in Python is by just giving the little star in front of your variable. What that will do is that it will allow you to use multiple arguments, because whatever is here will be converted to a tuple, which is roughly an array in other languages. Just an array that you can modify, but again, we'll be touching that later. So if I have this sum of numbers, I can give it a bunch of numbers as arguments, 7 or 8, -9. And that will work. I can remove numbers, and that'll still work. All that's doing here is just, the function itself is very simple. It's just taking every number and adding it into one sum and then returning that. So the function itself isn't complicated. But what's important here is that numbers is just one argument that we define, but when we actually using it, we can give it multiple different arguments. And this can be used in combination with everything else we've seen beforehand, so you can do more complicated functions. And now here, again, just a quick loop. We're using a for loop, and we're looping for the numbers in this numbers, if that's a bit confusing. So what we're doing here is for every element within this tuple. A tuple is roughly like an array. Again, we'll be touching it soon. Next thing we'll be touching on is strings in Python. Strings are immutable. In some other languages, they may or may not be mutable. Another key difference in Python in the way that strings are implemented is that you don't have a character type. So if you look at just one character of a string, you don't get a character, so you can't do character functions per se. You just get a string of 1. So strings are made of smaller strings, which can be a bit confusing. But it's not a big worry. There's many ways around that, but we won't be touching it on this workshop due to time. Now, how do I format strings? So earlier I was formatting strings when I wanted to print hello, name of the person. So in this case, I'm just defining a string hello and another string world. And now here I'm just going to print out hello plus world. So imagine you have two strings, you add them together, you just made a new string. So I run Python for this file here, strings.py. Getting other stuff here, which we'll be touching on later. What if I make this full screen? When we look here, we're seeing hello world. So that's one way you can format strings. And then if I want to as well, I can even add a number, which is a different type, but in Python you can do that. So if I run this again, we look at the first, and what did I do? Yeah, so that is because it is an integer and it just gives you an error. All you do here is put it in a string to just quickly convert it to a string, but then that would work. Now if I run that, it works again. Now I put a 3 at the end. Now this can be, if you're doing some more complicated, this can quickly get confusing when you're reading at code. So a slightly better way, at least the way I do it and some other people do it, is use f strings, which are like formatted strings. So all you do is, right before you use your quotation marks, which can either be double quotation marks or single quotation marks. In some other languages, you would just be double quotation marks, but in Python, you can use either. You put an f in front of it. And then when you want to put a variable within that string, you just put that variable and you enclose it between two curly brackets. So what that's going to do is within that string, it's going to input whatever variable goes there. So in this case, I have a prompt, and then space, and then a name. So old joke here, it's probably a dead meme at this point, but how are you? My name is, as a prompt, and then here's Bodie McBoatface. So now I'm printing that here. And actually, I'll just use one here. Appears, and if you look at the console, it's now going to be how are you? My name is, and there's no space, but there's space in the way we formatted it, and then it has that there. And then again, if we have other stuff here, that's always going to be there, like a constant, like let's say we put a number. When we rerun this, you can see at the end, there's a number. But now this is a bit easier to visualize because you know roughly how it's going to print out. And it does look a bit cleaner than having pluses everywhere. Now quick string functions. How do you make something all uppercase or all lowercase? Well, if you have a string like I do have here, defined as A, then you can just have that A dot lower or A dot upper with parentheses because it is a function. And there's not much more into that. It will either make it uppercase or lowercase. So in this case, lowercase for lower, uppercase for upper. Now this one will kind of tie into lists, and same thing with for splitting and joining, but we're going to be touching on lists right after this. But let's say you want to split a string in accordance to some pattern, for example. So in this case, we have split space this, and then this just a return character. And then oof. So if you were to just print this, it would do split this, return oof. But now we're doing a dot split, and as an argument, we're giving it the space. So now it's going to look at every time there's a space character, it's going to split it. And then the end of it, it saves it puts it as a array, something that you can iterate over with. So if you actually run this, you can see now it is a list, a split, and then this oof. It split it according to every time it found a space. In this case, there's only one space. Now we have this next line where it prints this workshop is boring. Then dot split at every S, and then we also give it this new argument as a second optional argument, which is 2. What it's going to do here is it's going to split at every time it sees an S, but it's only going to do it 2 times. After that, it stops, and whatever's left, it puts that as the last element of the array. So now we look at the example here, where it runs this, but now it's missing the S because that's where it split it. Work, and then we'll put shop. Again, the S here is missing. And then is boring because the rest. So even though we have an S here, this is the third S we encounter, we don't care anymore. We're putting the rest as its own element within that array. And then lastly, here split but with no arguments, which a lot of times might be the default way you might use it. What's happening here is roughly close to this space, but it is different. So in this first example that we had, when we had split and just as a space, it's only at the space characters that it's actually going to split. Here, when we're splitting it with nothing, it's going to split to any empty character. So that could be a tab character, a return character, a space, obviously. Anything that will be an empty character, it will split it at. So when we actually print this statement out, this is the third one here, it splits it at every word. But for example, if we had a return character, you can see it still splits it because a return character is also an empty character. Then lastly, for strings, we're going to look at how to join them. So now let's say you do have a whole array of strings, for example. In this case, I make one big string like this, and then I split it. So now it would be, as you see in these previous examples, an array of strings. Now I'm gonna pass this array per se. Here I could have saved it as its own variable, but I didn't, which actually is a bad practice. But then I'm passing it through this join function. This join function, I actually call it on this string. So what this is going to be doing, it can be a bit confusing when you see it, but what essentially is doing is that it's going to take each element of that array, and when it's going to join two of them together, it's going to put whatever is here in the middle. So you could put a space, but you could also put a dash, for example. So now what essentially happens is that it splits all these into separate words and then puts that all into one array, and then joins them all back together with a dash in the middle, which, as you can see, as the last example here. And this can be very useful when you can't think of an example off the top of my head, but I have used it in past assignments when I have to do some formatting, but it can come in handy. So that's why I'm showing it here. Now lists. I may have used array and list a bit interchangeably in this workshop. In Python, they're basically the same. They're not technically the same thing, but at least the way I use it, they basically are. If you worked in other languages such as Java, for example, there's a clear distinction between what an array is and what a list is. An array is going to be a fixed size, and a list, it's of dynamic size. You can increase it, you can decrease it however you want. In Python, you don't have arrays in that way. You just have lists. So you can essentially make the array that you can dynamically increase in size at any moment, and there's no problem with it. If you do want to have one that does decrease, that can decrease or increase, you would have to use a tuple. The downside here is that a tuple, the elements themselves, you also can't change the values. So whenever you create a tuple, it's completely immutable. So you cannot change the values of it. You can still access the elements of the tuple, you just can't change them. Another quick thing is that you can use a lot of the array manipulation things, functions that we're going to use here on strings, because strings, they are, in other languages, they are just an array of characters. In Python, they're not, but you can still use a lot of the same concepts on strings. Another note that I might have said earlier, so lists are mutable and strings are immutable. So in case you don't know what that is, essentially that means that you can't actually change the value of a string. So once you define that string, it is what it is. You can do other things, but once you've changed that, it doesn't change the original string. You'd have to reassign it to another variable. When something is mutable, you can actually change the values inside of that variable. So lists are mutable. So let's say at index 0, you could change what that value is. While if you do that on a string, you'll get an error, which I think we do touch on soon. Because the other thing, in some languages like MATLAB, indexing starts at 0. So when you have an array, you start at 1. So you do a 1, 2, 3, 4, and so on up until n element. In Python, it starts at 0. So you start at 0, 1, 2, 3, and so on. Another quick thing that I'm probably, again, going to touch on real soon is that when you go up to a certain element, where you're doing, like, for example, the range function, or you're going for a sub-array, it's exclusive. So it's not going to include whatever the last element you want. It's going to exclude it, but we're going to touch on that real soon. So in some languages, you could do something here, like let's say if you had an array, you could do array.length to get the size, or dot size, or dot count, depending on the language. They all implement it slightly different, but you can do dot and then some function to get the size of your array. In Python, you can't do that, but it's still very easy. You just use the length function, so length, and then you pass it whatever you want to know. So in this case, I'm printing two different things. So in this first one, I want to know the length of the array that just contains 1 and 2, and this other one, I'm going to put a string. So now if I run this, .py, I get 2 because I only have 2 elements here. And then I get 4 because I have 4 characters here in this string. So what the length of the string is, it is 4. Now, subarrays and substrings. You don't really need an extra method to access a subarray or substring, unlike some other languages, such as Java off the top of my head, where you would have to call a function just for that. You can access them the same way you would just access an individual element. In Python, to access an individual element in like most languages, at least any of the languages that I have touched, use square brackets. So here, what I'm doing is I'm defining an array, and then it's just 0, 1, 2, 3 up until 9. So as you can see here, I define that as R, so A double R. Now I want to do some manipulation on it. Let's say I want to know what not the first element, but the element at index 1 is. It's going to print out 1, because if your indexing starts at 0 and you want to know 1, the element at index 1, you just give it this and it returns 1. Now let's say I want to do a subarray. Let's say I want to go from 3 to 8. So what I do here is I pass where I want to start at. I give it a colon, and then I give it the second argument, which is where I want to go up to but not including, because it is exclusive. So here when I print this out, it's going to give 3 because it's starting at 3, and then 4, 5, 6, 7, and then it doesn't print 8 because it's exclusive, so it wouldn't print that element in itself. But if you did want to print that element, then just increase it by 1, and boom, now you have that 8 included. You don't always have to do this. Let's say that you want to go up to the last element of the array, and you don't want to always give it the exact index of that last element, because sometimes you might not know. A lot of times you might not necessarily know it's going to be on runtime because you're performing a bunch of functions. You don't exactly know what's going on, but that's not a worry. You can just leave it empty. It's an optional argument. So now if I do this, it'll start from 3 and it'll go up to the end of the array. So it'll go from 3, 4, 5, 6, 7, 8, 9, 9 being the last element of the array. And then you can do the same principle but in reverse. Reverse being that, let's say I don't care where it's starting, like I always want to start at 0 and I want to go up to a certain element, let's say element 7. 0, 1, 2, 3, 4, 5, 6. But you don't have to put 0 either. You can just omit that. If I run this again, it prints out the same thing. So when you don't give it an argument here, it's going to give you a default. And then if you really want to, although it's not directly useful, you can just put a semicolon. All that's going to do is going to return every element in that array, because it's going to start at 0 and it's going to go up to the end. It's not that useful except in very, very specific cases. And then here's a cool feature in Python that's very unique from other languages. If I can scroll correctly, which is that you can use negative indexing. Now, in a lot of other languages, if you give it a negative value when you're trying to find an index of an array or a list, it's going to throw out an error. It's going to say it's out of bounds. There's no element at -1 that doesn't exist. In Python, that isn't the case. So again, in other languages, you might do something like, let's say array, and then I want to get the last element regardless of how the size is. So mathematically, I have to find the length of this array, and I have to do -1, and I would get the last element, which is 9 in this case. In Python, they made it a bit simpler. So all you can do, you can omit the length array, and you can just give it the negative value. And now that'll give you your last element in your array. And you can use this principle up to, like, let's say 5. 5 being in the middle, but let's say you give it 3, you'll get 7, which is the third last element. But if you go up to a certain value, like say I could give it 12, now I'm going to get an out of range because there's no 12th last element in this array specifically. But if your array was even bigger, then you wouldn't get an error. So you can still go out of bounds. It's just that you don't directly go out of bounds when you go into negative, because when you give it a negative, it just starts from the end. Right. So now let's say whatever. I'll just sneak peek here. So now you can use this principle with what we just saw in terms of subarrays. And you can do very cool things where you can go from the third element up to the second last element if you want to. So that would be from the third element up to the second last element, and that'll print you out this. And then you can switch them around whatever way you want, depending on whatever you're doing. So now we're going to move on to some small Pythonic things you can do, which are very nice. When you're working on projects. So if you worked on pretty much most languages, let's say you wanted to find an array of length or size 8, and you'll want to initialize it all at a certain value. In most languages, you'll have to define your array, give it a size, and then you'll have to loop through it all, and then give it each time a unique value. Or it can be the same value for everything, it doesn't really matter. In Python, you can do that all in one line. So all you have to do, and it's, again, some things we've already covered at this point. So for example, we have a for loop here, for I in range of 8, right? So we're essentially looping from 0, 1, 2, 3, 4, 5, 6, 7. And then we give it here, which is right beforehand, is we're giving it I, but it can be 0 if you want all your elements to be 0. I, because I is going to be the elements we're going to be looping through, so 0, 1, 2, up until, but not including 8. And then you put all that between square brackets. And then now we're printing it here, just as an example. But actually, I can just call it here. So now you see 7, which is a variable I defined here in line 31, is a list, or a list from 0 up until 7. And I did all that in one line, where in most other languages, you'd have to make this in like 3 or 4 lines. So you can definitely make code very simple and easy to read in Python. And then lastly, which is something you might have noticed at this point, is that since the variables can be of any type, lists and tuples, by consequence, can be of different type of variables, different type of values. So again, in most of the languages, when you define an array, when you define a dictionary, when you define anything, its values, it all has to be of the same type. So let's say I'm making it an array of integers in C. I have to say that this array is all going to be integers. In Python, you don't have to do that. In Python, for example, here, I have 3 different types. So as my first element, I have an integer. As my second element, I have a string. As my last element, I have a float. Most languages wouldn't like this. They will throw you out, like, I don't know, 2 or 3 different errors because it wouldn't understand what you're trying to do. In Python, that's not the case. In Python, it'll just do it for you. It will give you an array that are of different type of variables. Doesn't mean you should necessarily do it. It can be a bad practice in a lot of cases, but there are certain scenarios where you might want to, let's say, have integers and floats, for example. And you don't want it giving you out an error because of that. So that is something very nice that you can do with Python. Oh, we're pretty good on time. Let's drink more water. So lastly, we're going to touch on classes in Python. They're not radically different from most other languages. So I guess not if you're coming from C, because C doesn't do object-oriented programming, but if you come from a lot of other languages, as C#, C++, Java, any of these other languages that do use object-oriented programming, or at least allow you to do it. So you might recognize the structure, right? Python doesn't do anything crazily different. So here we're going to say it's going to be a class. We give the name of what this class is going to be. Nothing crazy. And again, because we're using, it's an indented language, instead of having curly brackets, and I guess it goes for for loops and everything else, instead of having curly brackets, we just put a semicolon and everything else is indented. So the first argument, the first function we have here is init, and this is a built-in function for Python. So this would be our constructor function. So let's say I want to, every time I call a new instance of square, I want to define it with these properties, with these values. So here again, you use def because it is a function, and then you do a double underscore init double underscore, and then you give it all these arguments that you want. Quick disclaimer, something that I guess Python does do slightly different is that the first argument here that you give, and this will be for every other function, is going to be self. And self is always going to be a reference to that object. It's going to be a reference to itself. If you rename this to Apple, if you wanted to, it'll still work. But Apple is not going to be what you think it might be. It's still going to be a reference to the object. So In most other languages, you might just do this, for example, size and then coordinate. But in this case, now you'll get errors because size is a reference to the object itself. It's not going to be a number. So you have to give it self. When you're actually using it, when you're actually defining it, you won't actually type anything into this. It'll actually still be two arguments that you pass through. And so here's what we're doing, for example. So self.size, self.coordinate. So and then equals size equals coordinate. So what we're doing here is that self, again, is that when we pass it down here, it can be anything else, but the convention is that you make it self because that's what everybody uses. So it's just the easiest to immediately understand. A dot size because it is the size for that specific object. And here we're making it size and coordinate. And then these are public ones. So whenever we do call the instance later and we do it dot size, we can get the size that it is directly. It's public. If we want to make something private as a variable, give it a double underscore at the beginning. So underscore underscore private, and I give it this, and if I try to access it later, it won't work. So now let's run this. Open the interpreter. So let's say I'm going to make I'll define it as s square 2 and 3. Now s dot size, that'll give me 2. I can do s dot coordinate, that'll give me 3. But if I try to do private, it'll give me an error. It says it doesn't have the attribute because it's private. We can't directly access it. So we won't touch the other like just normal functions. If you use object-oriented programming, as long as you're still passing in self as the beginning, every other function is going to work as you would expect it, unless you're doing something very weird. But at that point, that's on you. Most likely not on Python. So now we're going to be touching represent and string, which essentially do the same thing, but they are used for two different cases. So let's say if you want to print out what that variable is going to be, you can pretty much go ahead and not use define represent. You can just use string. So that's what we're doing earlier here in our terminal, is that in this instance, this is going to be string and this is represent. You can essentially have them do the same thing, but by convention, you don't really want to. The main difference is that the first one's string, when you're printing it out, it's just going to be a bit easier for the end user. It's going to print out, like let's say like in an English sentence, so square is 10 units big and is at coordinates 2 and 3. While represent is the way the object is represented in Python. So when you do this, you can do anything you want, but it's up to you. But you should do something roughly like this, which is the way that we could have defined it, right? We're doing square and then we're just naming out the variable. So size is equal to 10, coordinate is equal to whatever the coordinates are. So they can accomplish the same thing, but usually you want to reserve one thing for actually representing what the variable is, and another one for just printing it out in a nice way for the end user. If you want to know more, you can just Google. Just go on Google, and then you'll probably get a Stack Overflow forum of somebody asking what's the difference, and then somebody else explaining it. That's pretty much where I got the answer from. And then lastly, we're going to be touching on some other functions in some other language like C++. It's like function overloading or operand overloading. But essentially, if you want to know if a certain object is equal to another object. So again, if you come from a language like Java, for example, you just do equals this object equal to this object, and you have implemented the equality function. It's probably going to give you false because they're technically not the same instance of the object, most likely. But if you don't want to care about that, you just want to know whether the object's variables are the same, basically. In Python, you would implement it as this. as this underscore EQ underscore underscore. And then again, you pass itself because you always have to, and then you pass other. And all we're returning here at the end is we're returning a Boolean statement. So here we're returning the size of this object is equal to the size of the other object. Other being the argument we passed through. So self is a reference to the object itself, and other is a reference to the other object. When you're actually using it, you're not going to be doing this object dot underscore underscore EQ whatever. I'm not even sure if it'll let you. It'll probably give you an error. But you can use it normally, like we're using here, where we're using a double equals. So this object, which S square is being defined here, is it equal to this object according to its size, because that's how we've defined it. We don't care in this case whether the coordinates are different, which is whether the size is the same. So we have this as a statement. And when we have it printed, right, we get false here because the size is 20, and in this case it's 10. But we'll get true here because the size is 10, and the size is 10 here. Now we can do other stuff like is greater than, is lesser than, is greater than or equal to, is lesser than or equal to. We knew all these other operands. However, we haven't implemented here, so it won't work. If you do want to know what all the other ones, I would just recommend looking at the Python documentation. If I were to show it here on the spot, it would take quite a while. And I guess that's another thing I could say is a lot of these errors that you'll get in Python, a lot of the times, unless it gets into libraries that you're using, the errors themselves are very simple. Python errors are very descriptive. They have, they'll give you a stack of what ran, and it's very easy to debug. So whenever you're getting errors in Python, Python will usually help you out to try to show you where your error is. An error that I might see some of you in the future getting, which that one can be a bit hard to debug, is an indentation error. So as I touched on earlier throughout the workshop, everything is indented. There's nothing that you put like between curly brackets like in most other languages. It is indented, which means that the indentation has to be consistent throughout the language. So at the beginning, you're using 2 spaces as your indentation. You have to carry that throughout the rest of your file. So every time you indent, it has to be 2 spaces. Let's say you make it 4 spaces, then the rest has to be 4 spaces. If at any point you use a tab or use a different number of spaces, if you're using spaces, it might not throw an error, but it'll do something unexpectedly because it might think whatever code you're running is in some different block. But if you're using spaces and tabs interchangeably, and you're not converting your tabs automatically to space, you'll get an indentation error. In terms of debugging, what I would recommend is, obviously when you're coding something out, be consistent. Either use tabs or use spaces, or in pretty much most text editors, you can go in the settings for that text editor, and let's say you convert all your tabs automatically to spaces. So even if you press tab, it'll get converted to spaces. I won't show you how to do it because not a lot of time, but that's one way you can fix it. And then the other way you can fix it, let's say you're looking at somebody else's code and they screwed it up, they have this because they didn't even test it before they gave you the code. Then what this point you can do is, it'll depend on what text editor you're using, but then you can go into the settings for that text editor and you can turn on something like invisible characters, and at that point you can differentiate between tabs and spaces very easily. If not, it's gonna suck and you just might have to go line by line until you figure out what the error is. That's the only error that's a bit hard to debug, but you only really go through that once if you're looking at somebody else's code, and then pretty much anytime you're typing, as long as you're being consistent, you'll never really run into this error. Any other errors, again, they'll be easy to debug because it'll pretty much tell you exactly what you're doing wrong. So this will conclude the end of the Python workshop. Thank you for coming. Again, if you want to get involved with either us, the UAIS, the Undergraduate AI Society, we focus on AI and machine learning for undergraduate students, because although the University of Alberta is very advanced when it comes to AI, it's mostly restricted to master and doctorate students, and the barrier of entry is a bit higher when it comes to undergraduate, so we try to focus for undergraduate students to try to make that more accessible. And then also again, a big shout out to Ada's team. I don't know if you want to plug yourself into exactly what you guys do, but they have helped us a lot in this. So if you're into what is this STEM? Yeah. Anything STEM, look into them. Yeah, thank you for coming.